to conferences all the time is the main driver for progress in your skill set and also your relationship, and basically any professional can become a better professional by attending conferences.
It's not the standard, okay? It's a movie theater, but the visual is great and the sound is great, and I've seen a lot of room and space, and I think it's organized well.
Seeing all the people here today and they're excited about stuff, you can see the energy and the desire to learn and do new things.
And I was positively surprised about the depth, the technical depth of the sessions, and how that makes the tester part of the team.
I think developers do benefit from coming to QA conferences, just the same as testers can benefit from going to dev conferences. You've got to have a broad understanding of what's going on.
It's really inclusive. I would say it's super diverse. People are really open and friendly, and it's really organized.
Conferences are well worthwhile just for the ideas that they spark in people. When people come back to the office, they're full of ideas and they're all energized up.
Hi, my name is Andrei Tognolo. I'm from Brazil, but currently living in London, where I work for TransferWise as the tech lead of the engineer experience team. My speech is about Test at TransferWise, the strategy that we have been following in order to achieve high quality release in a microservice architecture.
Thank you very much for joining me today. Today I'll be talking about Test at TransferWise, the challenge to test a system with more than 300 services. My name is Andrei Tognolo. I'm the tech lead of the engineer experience team at TransferWise. I've been working for TransferWise for around 4 years now. Previously, I worked at companies like Dexo and Potworks. Before I get into the content of this presentation, I think it's worth giving a couple of disclaimers. The first one is that by no means things are perfect at TransferWise. Sometimes we watch a presentation in a conference and then we think, oh, in my company, everything's so hard, but these guys, they really figured out a perfect solution. That's not the message that I'm trying to convey here today. We still have many challenges to face. Also, we have different views across the company. We have around 450 engineers, many different teams, and we try to give as much autonomy as possible for the teams. So if you talk with different people inside TransferWise, you're going to see probably different views, the different testing strategy that they have in their own team. But of course, we try to have somehow a coherent vision. And also, we are in a journey. I think that we are in a journey where we're discovering what works best for us. And I'll be sharing this journey with you. So maybe in 1 year from now, this will slightly change. And for those that don't know what is TransferWise, since the talk is going to talk about the TransferWise, how we test at TransferWise, I think it makes sense for us to introduce TransferWise. So TransferWise mission is money without borders, instant, convenient, transparent, and eventually free. We started as a service for you to send money abroad. Nowadays, we have different products, like, for example, you can hold money in different accounts, in different currencies. And also, we have a plastic card that you can use to spend the money that you have in your account. Nowadays, we have over 8 million people using TransferWise, and we process more than 4 billion pounds in transactions every month. So by these figures, you can imagine that test is really important for us. From a technical perspective, we have around 450 engineers. We have around 400 services running in production. Our stack is mostly JVM. We run on Kubernetes. We use a lot of Kafka and a mix of different databases. And here's an agenda for us today that I'll go through. So first of all, we start talking about the testing strategy in a monolithic architecture, so that we can try to understand what are the things that we probably want to get and continue doing in a microservice architecture. But mostly important, what are the things that we probably want to avoid? Then after that, we'll be talking about how we can define a testing strategy, or at least one way of doing so. And then we're going to dive into the testing strategy at TransferWise itself, where we will be talking about how we split into 3 different categories. So diving straight into the testing strategy in a monolithic architecture. This is one example Of course, we have different flavors, but I'll use this one as an example. So in a monolithic architecture, you have the first phase, let's say, is coding, where you're coding, then you push to a platform like GitHub, and then that's going to trigger your CI environment. Here represented by Circle CI, where you run your automated tests. As a result of that, you have a deployable that you're going to deploy in an environment. And what used to be quite common in a monolithic architecture is to have this enterprise-wide testing environment, where what I'm calling here staging. And then there you're going to perform some exploratory testing, check that everything is working as expected, then we promote this version to production. And I want to pay attention to two steps in this process. The first one, I want to talk a little bit more in depth about the automated tests. When you think about the automated tests that we're running in our CI, I think that we can split them into two different categories. The intercomponent tests, those tests that only need one component, one part of your application to be able to run, and those cross-component tests, like for example, end-to-end tests, where usually you need different components of your application to be able to run. And we can talk about many disadvantages of the monolithic architecture, but I think we need to recognize that actually there are some things that are actually easier in a monolithic architecture. For example, running this cross-component test, because all the components, they are already bundled together, which won't hold true in a microservice architecture. We're going to explore more of that during the presentation. The other part that I want to talk about in this strategy is this exploratory testing phase. And then what was quite common to happen is that because we have different teams working on the same application, it was often that one team is working on feature, performs the exploratory test and gets to the conclusion that is ready to go to production. But while at the same time another team, they have another feature, then they find a bug. So they say, hold the release because I need to fix the bug that I found in my part. And then at this moment, we have two different teams that in theory, they should not be like dependent on each other, but they are actually one is blocking the other. And we have many, many techniques to try to avoid these kind of scenarios. But we got to at some point that we got to a conclusion that, you know what if we simply avoid these problems by splitting our monolithic application into microservices. So if you think, one of the main advantages of microservices is actually the ability to deploy one service by itself, independently of other services. And independently is the important part here for us, I guess. And I think it's important for us to have this principle in mind throughout this presentation, because when thinking about our testing strategy, if we think about a strategy that goes against this principle, it's possible that we end up not getting the main advantages of microservices. Now, if you think about that monolithic architecture application, and then you break the application down, each one of the components then become a service, then what we would have is something like this. You have different services. Each one of the services, they have their own path to production, an independent path to production. So the service A has its own CI environment, and the B and C, so on and so forth. They run independently. Now, if we get back to those categories of tests that we mentioned before, now we don't have components, we have services, right? So there are two categories that I'm splitting here. The first one is the test in isolation, which is a term that I'm going to use throughout this presentation. And when I say test in isolation, what I mean here is that the test that only needs one service to run. And then for this one, it's fine. You just simply run your CI. But how about the cross-service tests? Those tests, like, for example, end-to-end tests, that you need multiple services, that you like to have multiple services to be able to run. Well, for this service, it's a little bit more complex. You could argue, for example, that in this case, if you only have 3 services, you know what? Let's just start the 3 of them using Docker containers inside the CI, and then we run the test. And I'll tell you, well, if you have actually 3 services that you need for your test, do it. Like, I don't think there is a big problem. But now, if your system starts to increase and then actually need many, many services to run, then that becomes impractical. Now, what can we do then? If you cannot run in our CI our whole system, our whole microservices. One strategy that is quite common for people to think about is, let's keep the test in isolation in each one of the CIs independently of the services, but then after that, let's have one environment, which I'm calling here staging, where you have all the services there, and then you deploy a new version of the service that you are deploying, and then we run some sort of cross-service test, and then if everything goes well, then we promote to production. And then my question for you is this a good testing strategy? When I think about a testing strategy and I try to evaluate whether it's a good one or not, what I try to have in mind is what is the hardest part of a test. If you think that a test can be split into given, when, and then, what is the hardest one? Most often, get conclusion is the given, especially because there are some hidden assumptions we're making given. So if you think about this testing strategy, to have this staging environment that we want, what is the given for that? It's something like this. Given that I have a production-like environment, and that by itself is pretty hard. It's pretty hard for you to mimic production when we're talking about 300, 400 services. But supposing that you have that, the other part of this given is that you want all the other services working properly. So in this example, if you're releasing the service A, you have a new version to test of the service A, which potentially has bugs. That's why you're testing, right? And while you want all the other service to have a stable version, you want them to be working fine. So far, no problem. The problem comes when you are deploying also a new version of the service B. And then once you have many services being tested in the same environment at the same time, then you start having many problems. Because this basically the solution is that you'll never be able to have a truly stable staging environment, at least I believe. And that applies to some extent to both automated and manual testing. And I'm not the only one saying that we should try to avoid this kind of strategy. ThoughtWorks in their tech raid in 2017 put on hold the enterprise-wide integration test environments. And this whole category basically means that we should try to avoid. But the question here is, we are used to have these end-to-end tests running pre-production, and we are used to get the advantages that these end-to-end tests they give us. So if you're saying that we need to avoid this enterprise-wide testing environment, this strategy doesn't really suit quite well microservices, what should we do then? And that's when we get to the second part of this presentation, where I'll be talking a little about how we should then try to define a testing strategy. I think that we should start saying that there's no silver bullet, at least we haven't found one. There's nothing that we know that's going to work for all the companies. So because of that, what I believe is that we need to ask ourselves, what are the most common instances that are happening in our company? And then for that, what we've been trying to do at TransferWise, we've been trying to make it easy to report and coordinate incidents. So for example, you can see here that we have a Slack bot where you can say, hey, there's an incident happening. You can put the teams which are related in this incident. It's going to find the people on call for these teams. And then it's going to create a Slack channel where these people are going to actually resolve the incidents. And after that, we're going to collect a couple of information related with the incidents, where we're going to have weekly meetings to discuss the most important ones, trying to understand what are the patterns that we are seeing, what are the things that are creating more incidents, and how we can improve our testing strategy. And also we collect metrics. Like for example, a simple one that we collect is the percentage of rollbacks that we have. And again, here you can filter only by your services, and you can see how we're trying to figure out what are the patterns so that we can keep improving. Now, with that in mind, then I think that we can get straight into our testing strategy at TransferWise. And I'm going to split into 3 sections, and the first one is going to be testing isolation. So the idea, if we want to avoid a staging environment, what we should actually be trying to do is to put a lot of focus on the testing in isolation, those tests that only depends on one service to run. And we can talk about different aspects of what a good test in isolation actually means, but I'm going to focus on 4 points here. The first one, I'll be talking about the test pyramid. I think that everyone attending have seen this pyramid, and anyone working with a monolithic application in the past or even nowadays knows how hard it is to keep this shape. And the idea basically in this pyramid is that we want to have as much as possible unit tests because they run really fast. And that makes a lot of sense when you're talking about a monolithic architecture that has thousands and thousands of lines of code, because in order for you to test the application, you're going to need thousands and thousands of tests, which if they don't run very fast, then you're going to end up having hours and hours of your build running. But the thing is, we are talking about microservice architecture, where services they are supposed to be small. So what we see is that more and more teams at TransferWise, they're getting to the conclusion that they should put less focus on the shape of this pyramid and more focus on the confidence. Because if your service is not very big, even though not all your tests are unit tests, it's still okay if they take a little bit longer because you don't have that many of them. And something very important is that although the unit tests, they are pretty fast, that's awesome, but also they are the ones that give us less confidence. So then the conclusion that the teams are getting is each one of the services, they need to follow what is best suits for that service. If it's the shape is actually a pyramid, be it if it's a diamond, that's okay. If it's even a cone, that's fine, as long as you're focusing on the confidence that the tests are giving, and also that your build does not take more than, let's say, 10, 15 minutes. But it's pretty hard to change this mindset because we've been told for a long time about this pyramid that we need to focus on it and etc. And then we end up doing things, I believe, that they are counterintuitive, actually, that they reduce our confidence. Let's take, for example, this test. You have a test that calls the class A, that calls the B and C and D and so on and so forth. This one is not on a unit test. But in our obsession to make this a unit test, it's very common that we go there and we end up mocking the class B. But the problem is that creating a mocks reduces greatly our confidence in the test. So I believe that we should be trying to avoid this kind of scenarios where we reduce our confidence. Another example where we try to use mocks, I think is in cases where our tests, they depend on something. There's an external dependence, like for example, Kafka or a database. I think it's arguable that that made sense 5-10 years ago, but nowadays we have Docker. How long does it take for us to spin up a Kafka Docker container to run? Like 5 seconds, something like this? Maybe the same is even for the databases. So if we can use the reimplementation, why not? You might be thinking now, so are you saying that we should not use mocks at all? That's not exactly what I'm trying to say. What I'm trying to say is that I think that I try to use the real implementation as much as possible because that gives more confidence, and try to only use mocks or when it's something that is external to my service and we cannot use a container. So in this case, for example, I have a test that calls the class A, which is in the service, the one class that is in the service A, that then calls the service B and the C and so on and so forth. In this case, I would say it makes sense for us to mock the service B. But we need to be careful because every time that we mock, we are actually making an assumption that that's how it's going to work in production. Actually, more than that, we are making an assumption that that's going to keep working, which is pretty strong assumption. So when we're talking about mocks, we need to be careful with contra guarantees. We need to have some sort of contra guarantees. When I think about contra guarantees, I think about 2 categories. The first is what I'm calling here schema. So imagine in this case, the service A is calling the service B to create a transfer. And in the payload, we have the source, which is a currency, which is a string. In the response, we have an ID, which is an integer. That's the string, the integer. This is what we are calling here schema. And at TransferWise, because we run mostly everything as JVM, we can follow a strategy, which is the services, they provide what we call API clients. So the service B provides an API client that the service A can use then to talk with the service B. So the service A is actually not doing the parsing of the payload. It's actually using the classes provided by the service B. And then in this way, the schema is already there. It's already as part of the class that we are using. Of course, we need to be very careful when we are evolving the service B to make sure that we keep evolving the clients and that the servers are using the upgraded version. So there is some versioning control that we need to make to have the schemas guarantees. Now, the other part of the contra guarantees is what I'm calling here semantics. is when you go a little bit beyond that, and we want to check things. For example, if I pass a occurrence which doesn't exist, then I want to receive an error message. If we want to get this far in our tests, when talking about contract tests, we could use something like consumer-driven contract testing. But at TransferWise, we don't use them. Some teams, they tried in the past, but they are not using anymore. And the reason is because of two things, I believe. First is that they identified that the cost to make them work and keep them working fine is quite high. And also because the schema guarantees that we have with the API clients that I mentioned, they actually have been quite good on catching most of the issues that we had in the past. With the exception with enumerations, we still have some problems with enumeration. We need to improve on that. So if I talked about a couple of things that we can do to have a better test in isolation. But I think that there's something really important here is that we believe that as less coupled is our services, higher is our confidence from testing in isolation. A different way of saying what I'm trying to say here is that imagine that you have your service, you have really good tests in isolation for the service, you make a change, and you're about to release to production. If you are still afraid of making this deployment, it can be because it's too coupled with other services. And then in this case, what we actually should be doing is we should be trying to change the design of our system. But even if you have a very good design in your system, you have very good test in isolation, I think that still makes sense to ask the classical question. Can we catch all the bugs before they reach production? And I don't even need to see you to know what is your answer. Your answer is no. We cannot catch all the bugs before they reach production. Now, the question that follows that is, are we comfortable with that? Are we okay? Have we embraced, have we accepted this fact? And if we haven't accepted this fact, then what can we make? How can we then become comfortable of having bugs in production when we're dealing with money, for example? Well, the answer for this question, I think it's like pretty big and it's like really complex, and it's going to depend on from application to application. But I think that it starts with us accepting that not all the bugs, they are actually equally scary. So to give some context, in August at TransferWise, we did 2,400 releases. Most of them, they went fine, no problem with them. But some of them, they created incidents. And you can see here the incidents that we logged in August. And some of them, they are not even related with releases, right? A partner is down, it creates an incident. But some of them, they created incidents. So what we should be focusing is not only that we don't want the incidents to happen, we want the severity of the incidents to not be very high. So the severity 1 and 2, they are the highest ones. So maybe we can tolerate some severity 4 incidents that the customer don't even see, they don't have even impact for the customers. So not all the bugs, they are equal. Now, how we make then, how can we evolve on, once I have a problem in production, then this problem is not a high severity incident. That's part of this answer, I believe, that is the next section in this talk, which is testing in production. Along with testing isolation, we believe that the test isolation needs to come along with testing in production techniques as well. And we could talk about many different techniques. We can have there are talks only talking about testing production, but I'm going to focus about some of the key parts that have been working quite well for TransferWise. The first one is put a lot of effort in monitoring and observability. That's really important. Things that have worked quite well for us at TransferWise so far is to provide out-of-the-box dashboards and alerts, so that when for your service, you don't even need to think about what are the alerts that I need to have in my service. It has some by default for you. Of course, you can add on top of that your own. The other point is that business metrics, they have proved to be quite important as well. So for things like how many transfers have we created in the past 1 minute and things like that are pretty good, because they tell you that there's something wrong or potentially wrong. Doesn't tell you exactly what it is, but at least you know that you need to investigate further. And also distributed tracing for each we're using Agri has proved to be quite important. The other point is that I wouldn't be able to talk about testing in production without mentioning extensive usage of feature toggles or feature flags. And of course, not only about on and off, this feature is on and it's off, but also I can enable only for myself, only for my team, only for people who work for TransferWise, only for a small percentage of the customer, and so on and so forth. Another very important aspect of testing production is that we have smoke tests that we run in production. So if you think about these cross-service tests, we do have them, but they are running in production. Those tests that need a lot of service, they are running production. They're doing end-to-end tests. So they keep running every minute, and they test user journeys, like, for example, creating a transfer. And if we put a couple of these things that I said together, where we get is an automated canary release. And to be totally honest with you, we haven't get there yet. We do have some sort of canary release, but it's not fully automated as I'm saying here, but that's the direction we're going. So imagine you have your customer is accessing your production system where you have a couple of services there. Once you deploy a new version of this service, you don't want your customers to see this new service. You want only your smoke test to go through and test this service, run the smoke test, and then if it's working fine, then we can start enabling for our customers. We start with 1%, then 5%, keep monitoring, everything is going fine. We eventually get to 100%. Now, what I believe that is the message that I'm trying to convey in this presentation is that as better we get in the areas previously mentioned, meaning very good testing in isolation and very good testing in production, less we feel the need to have an integrated pre-production environment where we have many services running. But the reality is that we still feel the need of an integrated pre-production environment sometimes at TransferWise, especially for exploratory testing. The reason why is especially because we are dealing with money, so we have many regulations in place. For example, I cannot pretend in production, I cannot pretend that I live in the US, I live in London, so I cannot do that, this kind of exploratory testing in production. Because of that, we feel the need of having a pre-production environment with many services. And for that, I'll be talking about what is the solution that we have been using for exploratory testing. If you've been paying attention, at the beginning of this presentation, we were talking about the fact that this enterprise-wide testing environment is something that we would like to avoid. This stage environment we want to avoid because if you have one environment and many people are using, it becomes unstable. But what if I could have my own stage environment? And that's what we created. We created a tool, which is an on-demand production-like environment. This tool is ready for the engineers to use for around a year and a half. What the engineers can do then is that each one of the engineers, they can, using this tool, create an environment only for them. Once they create this environment, they have a URL that they can access, and then they can perform the tests that they want there. For example, they can create a transfer in this environment. Also, they can do whatever they want there. If they want to deploy a new version of a service, they can. Or if they want to even to turn down a service and see how the system behaves with that, they also can do. Now, this type of solution is quite complex to build because it's like you need to have a way of creating that on demand, and then you need to do it in a reliable way. So while creating this tool, we had in mind a couple of principles that I want to go through with you. So the first one is that we want it to be convenient. So for that, you can see here that we have a Slack bot where you can send a message saying create and the name of the environment, and then it's going to create an environment for you. We want this to be production-like. We want the same versions as we have in production. We want the same tools that we have in production. We want the same feature toggle values that we have in production, so on and so forth. And at the same time, we want this to be fast to create. So nowadays, it takes between 5 to 8 minutes to create an environment. And there is a compromise between production-like and speed. The classical example of this compromise is around databases. So in production, each one of the services, they have their own database, their own instance of a database. For these on-demand environments, what we do is that we have one very big instance, and actually we split this instance using schemas, because when you create a new environment, it's much easier to create new schemas than create new instance. It's much faster. So there is a compromise between production-like and speed. The other part is that, of course, we want this to be reliable. When I say reliable, is that when I fire the create command, I want to have at the end of the process an environment working where I can perform my tests. And don't get me wrong, this kind of solution, it's high demand, it's high maintenance, sorry. And the engineering experience team is the first line of this defense. And then what we did is that we created monitoring on the solution to make sure that it's working fine. So it constantly creates an environment and runs some smoke tests. For this part, I want to dive a little bit so that you understand the kind of things that we've been doing. So we have this thing called the big probe, which runs every 15 minutes. What it does is that it gets the versions from production of the services, creates an environment, runs some smoke tests there, and then if it sees that everything is working fine, then it promotes the versions so that the engineers, they can use. What happens if there's a new version of a service that actually does not work in this on-demand environment is that the big probe is going to fail and won't promote this version to the engineers. So in this way, we are able to have a more reliable solution. But even with that, the creation success rate is between 5 and 95. It used to be more like 95. We had some problems. Some weeks we got to 85. Now, that's something that we want to improve, and I believe that we can. We just need to put our efforts, and we're going to improve the reliability. But I believe that we'll never get to 100%. Maybe 95, 98 seems like a reasonable target. Because there's so many things that can go wrong when you are creating an environment that I don't think that's really possible to get to 100%, that you're going to understand that this information is important in the future. Also, we want low cost. So for that, first of all, it's ephemeral. When you create an environment, after 4 hours, it's going to get deleted. You can extend this time, but you cannot say live forever. It has to be ephemeral. And not all the services are there when you create the command. The create command, by default, is going to give you only the services required for you to perform a GBP to Euro transfer. But what if I'm testing something different than that? Well, if you're testing something different than that, then each one of the teams, they can create their own templates. For example, in this case here, we are using the command create the environment from the template, in this case cards, which is a template that the cards team created where they say what are the services that they need in order to perform their tests. And we try to create this solution with a product mindset. So for example, we ask our customers, our engineers, how likely would you recommend this tool to a TransferWise engineer? And then as you can see here, in general, people are pretty happy with the solution, but don't let me fool you, it's far from perfect. But so far, it has been useful. Now, the other part that is quite important is that so far, we have used this solution only for exploratory testing. And then you can be wondering, why is that the case? One thing that we could do potentially is we could use these on-demand environments as part of our path to production. So for example, in our continuous integration environment, we could run the test in isolation of that service specifically, plus creating an on-demand environment. And then we put the new version of the service A, let's say, and then we run the cross-service test there. And then my question for you is this a good testing strategy? Which is the same question that we asked when we were talking about a staging environment. Well, first of all, let's think about the problem that we have with staging. The problem with staging is that we had many services that we were testing at the same time, which is not the case here anymore because it's an on-demand environment, which basically means that you're only testing one service at a time, the others, they can be stable. So yes, we can have a production-like environment where all the other services are working properly. And the question is, why not? Why wouldn't we use this on-demand environment to perform cross-service tests pre-production? There are a couple of reasons. So first of all, it's going to add 5 to 8 minutes to your build because it takes time to create. But the most importantly, I think, is that your build will become flaky. You remember that I said, I don't believe you will ever be able to get to 100% of reliability when creating these environments because there are so many things to go wrong. And having a flaky build is not really something that we want, right? It's something that we try to avoid as much as possible. So that's a big disadvantage of using it. Now, the other part is about cost. If every build that we do, we need to create an environment that has like, by default, I think that the create command brings maybe 30, 35 services. I'm not sure how the cost plays a part here. Now, there are other maybe more philosophical points of view on that as well, which is why? Why do you even need this environment? Another way of asking is, why is test in isolation plus test in production not being enough? What is missing? Isn't it because our test in production is not at the level that we want? Isn't it because our services are too coupled, maybe? Why don't we run the same tests that we want to run in this pre-production? Why don't you run them in production now as our smoke tests? So these are some of the questions that I think they're a little bit of philosophical point of view, but I think it's quite important. So far, we don't know. It's a big debate that we are having at TransferWise. Some people think that we should, some people think that we should not, and we are trying to find our way on this. But I would like to hear your opinion as well. So join me for the Zoom that we're going to have after this talk, so then we can talk a little bit more. I want to hear your opinion. Should we use this on-demand environment as part of our path to production, and not only as exploratory testing as we use right now? So my time's coming to an end, and I want to do a little bit of a summary here for you. We believe that for microservices, we should try to avoid staging environments because they tend to be unstable, unreliable. The key for us to not feel the need of having a stage environment, we believe, is testing in isolation. Really good testing isolation, along with very good testing production. If we get these two things right, we feel less the need. But sometimes, for exploratory testing, especially at TransferWise, we still feel the need of having this pre-production environment. And for that, we created this on-demand integration environment as a solution. So that's all that I had to ask, that I had to tell you guys. Thank you very much. Do you have any questions? Let me take a look into this Lido to see if we have any questions here. Cool. So we got a couple of questions. Does the on-demand production environment have actual integration with the banks and involve actual transfer of money? That's a very good question. No, they don't. I mean, let me think. By default, no. So the services which are there, they're not talking with the banks directly. However, in one of the templates that people create, one of the templates that one team created is a template that actually talks with the bank. But there are some challenges here. First of all, that you can talk with the bank, but the bank cannot talk back to you. I mean, it can reply your request, but it cannot access you because as it's on demand, then the domain keeps changing, right? That the bank will need to call. So it's always you calling the bank. The other point is depends how the banks they allow us to talk with them. If they want some sort of allow listing or a white listing, don't want to use this expression, but this allow listing of the IPs, then this IP is going to keep changing. But for some banks that they actually don't use this allow list, then we were able to test calling the banks itself. I hope that answers the question. The second question here, do you do about backwards compatibility of services? What do you do about backwards compatibility of services? So I think that's probably something that we should improve a little bit at TransferWise. But currently, what we do is that as we are using the API clients, so each one of the services, they are giving a library basically to the other service to use. So what they can do is that if you're making a change that you know it's a breaking change, what you're going to do is that you're going to update your client, ask everyone that is using your library to update, search and check that no one is actually using the old version, and then you can safely upgrade to the new version of the service. Now if we there are some services already using gRPC, which would make this process a little bit easier, let's say, but not all our services are using gRPCs until now. How often do you deploy code in production? So that's up to each one of the teams. They are free to do as in the frequency that they want, as soon as it's ready for them. As I mentioned, we did 2,400 release in August, so I'd say like multiple times a day is probably the best answer here. Each one of the servers, they are going to act in a different way. And again, we're talking about being comfortable of having bugs in production. One thing that's important is some services, it's okay if you make a mistake. Sometimes it's like a backend tool that you can easily revert. A downtime of 1 minute is not going to like create a big problem, but some services, they're quite important and they are quite sensitive to any mistake that you make. So what we see is that the servers that they have like what we classify then as tier 1, they have less frequency of release to production because they need to be a little bit more careful with their tests, while the ones that they are like tier 4, which is the ones that they don't cause big problems if they go behave badly, then they tend to have more release. So these are the questions that I had here. I'm going to join the Zoom. So if you have more questions, I can talk with you guys there. Thank you very much.